Hi everyone, and welcome to Jam Academy. This is a continuation of the previous problem in which a car of mass 2300 kilograms moves on a horizontal road at a speed of about 75 kilometers an hour, and we were asked to determine the power required to sustain that car. Now keep in mind that the speed of 75 kilometers an hour is equivalent to 20.8 meters per second. We did calculate this in our last lesson. Now we are required to determine the power needed to drive the car up and down a 10% grade road. When we say the road is a 10% grade, it means that if the hill rises 10 meters vertically, it will extend 100 meters horizontally. It will actually help us to calculate the angle. What does that mean? It means if this is the hill, and if it rises 10 meters vertically, it's going to extend 100 meters horizontally. Let's call that angle theta. It means that the tangent of alpha, is going to be equal to 10 divided by 100, which will give us alpha to be equal to 5.61 degrees. So the inclination of the road is 5.61 degrees. Now the next thing that I would love for us to do is to draw the free body diagram showing the forces acting on the car. You have here the weight of the car acts vertically downwards. The normal force acting on the car is perpendicular to the surface, and there is a traction force acting upwards. So the one thing that I would like for you to see is that we can resolve the weight of the car into two components. This will be mg cosine theta. This will be mg sine theta. You recognize that the vertical component does no work because it is perpendicular to the direction of motion, but the horizontal component of the weight of the car does work and is pointed in the opposite direction to the displacement of the car. In other words, gravity does negative work as the car moves up. And therefore, if gravity does negative work, this is important. For the car to maintain the same speed of 75 kilometers per hour, it needs to provide extra power to counteract the negative work done by gravity on the car. Let me say that again. Now remember that the car provides about 10 horsepower to maintain the car on a horizontal road at a speed of 75 kilometers per hour. Now for the car to maintain the same speed up a hill or up an inclined plane, it has to provide extra power to counteract the negative work done by gravity. So we know that the work done by gravity is equal to mg sine theta, which is the component of gravity in the direction of motion, multiplied by the distance moved by gravity up the inclined plane. But the crucial part that I want you to understand is the extra power required to counteract gravity will be equal to the force of gravity mg sine theta multiplied by the speed of the car. So this is equal to 2300 kilograms. I'm going to take G as just 10. meters per square seconds, the sine of 5.61 degrees multiplied by 20.8 meters per second. So if we calculate all of that, we will have the power to counteract gravity will be equal to you have 2300 multiplied by 10 multiplied by 20.8 multiplied by the sine. Let me start this way to make it easy. 5.61 sine multiplied by 20.8 multiplied by 10 multiplied by 2300, and we will have here 46,766.8 watts. 46,766.8 watts. Now remember that automotive power is given in horsepower, so this is equivalent to 766.8 watts multiplied by 1 horsepower divided by 746 watts, which will be equal to 62.7 horsepower. 62.7 horsepower. So this implies that the power needed to counteract the total power required to drive the car uphill will be equal to 10 horsepower plus 62.7 horsepower, which is gonna be equal to 72.7 horsepower. As a matter of fact, we need much more horsepower driving the car uphill compared to downhill. Now here's the deal. What is the power required to drive the car downhill? Now, given that we have calculated the power needed to drive the car uphill, now I'm going to give you a homework. Your homework for today will be to calculate the power required to drive the car downhill. The hint in doing so is that the angle alpha changes a little bit. Find out how and how it will affect your results. Thank you, everybody. If you have a question with regards to what we've done so far, I will appreciate it if you ask in the discussion forum right below this video. Stay blessed and stay tuned. Bye-bye. See you next time.